The Unit Circle, an intriguing new way of learning the most important circle in math, by Abby, Lauren, and Morgan.
Let's face it, the unit circle is confusing sometimes. What are those angles? Why are they so important? What is that weird house sign? Oh, it's pi.
That's why we're going to show you some new ways of remembering the angles and where all the coordinates come from.
Because you can't know the unit circle if you don't know the basics.
To start off, let's review what a circle is in terms of math. A circle is a round figure whose boundary, the circumference, consists of points equidistant from a fixed point, the center. In the unit circle, we have x and y axes, which are perpendicular to each other and contain the quadrantal angles 0, 90, 180, 270, and 360 degrees. There are angles on the unit circle, and you should know them in degrees and radians. You might be asking yourself what a radian is. Radians are important because they allow you to view angles in terms of pi, so you can do much more with the angle measure than if you had it in degrees. The arc length formula requires the angle to be in radians. Now that we know why radians are important, it's time to learn how to convert from degrees to radians. To go from degrees to radians, take the degree measure and multiply it by pi over 180. This will give you the radian measure.
It will be easier for you to remember the radian measure if you have a pattern. We like to think of the angles in terms of the denominator. You may notice that the angles, starting at the positive x-axis, go 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. The angles with the 3's are closest to the y-axis, and the angles with the 6's are closest to the x-axis. The angles with the 4's in the denominators are in between. Now that you know the denominators, you can remember the numerators with this simple pattern. The numerators in quadrant 1 are only pi. The numerators in quadrant 2 are the denominator minus 1 in pi. The numerators in quadrant 3 are the denominator plus 1 in pi. And the numerators in quadrant 4 are the denominator times 2 minus 1 in pi. If you can remember which denominators go for each angle, you can use the pattern to find the numerators.
In the unit circle, there are angles that are in the same place but not the same measure. These are called coterminal angles, and they share the same initial side and terminal sides. To find coterminal angles in degrees, take an angle measure and add or subtract 360. And to find coterminal angles in radians, take the angle measure and add 2 pi. For example, 360 and 720 are coterminal angles. In radians, 2 pi and 4 pi are coterminal angles.
To fully understand the coordinates of the unit circle, you must use the Pythagorean theorem in an equilateral triangle. Each angle in an equilateral triangle is 60 degrees. If you draw a line down the center of the triangle, it forms two 30, 60, 90 triangles. Let each half of the bottom line of the triangle be S, each full-length side H, and the line that divides the triangle L. Since all the sides are equal in the big triangle and S is 1/2 of a normal side, then H is 2S. Now we can use the Pythagorean theorem to solve for the line down the middle, L. Let A be S, let B be L, and let C be 2S. When substituted, it is S squared plus L squared equals, in parentheses, 2S squared. When you square the 2S, you get 4S squared. L squared equals 4S squared minus S squared. L squared equals 3S. Finally, L equals S squared root 3. That is the length of L. So for a 30, 60, 90 triangle, the side across from the 30-degree angle is x. The angle across from the 90-degree angle is 2s, and the side across from the 60-degree angle is x square root of 3. In the unit circle, x is equal to 1/2. That makes the hypotenuse of the triangle, also the radius of the circle, 1. Therefore, the coordinates of the 30-degree angle on the unit circle are square root of 3 over 2, 1/2, and the coordinates of the 60-degree angle are 1/2 square root of 3 over 2.
You can also apply the Pythagorean theorem to the 45, 45, 90 triangle to get the coordinates for the quarter angles, or the ones that have a 4 in the denominator, in radian form. Let the sides opposite to the 45-degree angles be C, and let the hypotenuse be A. Using the Pythagorean theorem, C squared plus C squared equals A squared. Simplify this to 2C squared equals A squared. Divide both sides by 2, and you are left with C squared equals A squared over 2. Take the square root of both sides, and you are left with B equals L over square root of 2. By rationalizing the denominator, you are left with L square root of 2 over 2.
Now that you have the side lengths of the triangles, you can visualize the special right triangles in the unit circle to get the coordinates of the points on the unit circle. At 0 degrees, the coordinates are 1, 0. At 30 degrees, the coordinates of the point are square root of 3 over 2, 1/2. At 45 degrees, the coordinates of the point are square root of 2 over 2, square root of 2 over 2. At 60 degrees, the coordinates of the points are 1/2, square root of 3 over 2. The coordinates at the point at 90 degrees are 0, 1. Using reflection, you can change the signs of these basic coordinates and find the coordinates of the points in any quadrant. If you want to find a point that we haven't discussed, you can draw a radius to the point and make it the hypotenuse of a new triangle and use sine and cosine to find the x and y coordinates.
You'll need to know the sines and cosines of the fundamental angles on the unit circle. We'll use 30 degrees for our example. If you draw the radius of the circle at 30 degrees, it is the hypotenuse of a triangle. Now we can use trigonometry to determine what the sines and cosines are. Sine is opposite over hypotenuse. The opposite side of this triangle is the y value of the coordinate 1/2. Cosine is adjacent over hypotenuse. The adjacent side of this triangle is the x value of the coordinate. If you want to figure out the tangent of the triangle, you use the y value over x value, since tangent is sine over cosine.
Hopefully you have a deeper understanding of the unit circle after watching our video. You've learned about circles, degrees and radians, special right triangles, coordinates on the circle, and sine, cosine, and tangent.
Thank you for watching our video.
To Major Tom.